we just had a solar storm launch from the sun on March 1st. That plasma filament right there, really nice launch of plasma out, and we see this really nice canyon of fire afterwards too. See that right there, like this? And that is now headed towards Earth. In fact, it is sweeping by at this moment in time. And NASA detected this launch of plasma about 24 hours ago, and it was quite the impact, pretty severe. And so the question that we have right now here on Earth is this going to be a big geomagnetic storm? The forecast is for a G1 storm. It goes to a rating of 5. Maybe a G2 storm. Some other space weather forecasters are saying maybe we get a G2 storm. But that impact on the solar orbiter probe right near Venus at that time was quite significant. Let's give it a look, and let's also look at some other views of this plasma filament. So first off, here is the solar system. Here's the solar orbiter probe right there in front of Venus, and here is the Earth. And so I'll talk about that more later, but this is the geometry. The probe is right there. This is the magnetic field that it picked up. So these are different vector orientations for that magnetic field. Most importantly, I would say for the context of this discussion is we want to look here at the total magnetic field. And so we see that it was hovering around 15 nanotesla, which was already elevated above normal. And then it spiked all the way to 35 before starting to come back down. And look how rapid that spike was. That is clearly from a coronal mass ejection impact. That is from that plasma filament that we just saw launch from the sun, which was back on March 1st. And so I calculated a little bit of information for this so we can get a sense of the propagation speed of this coronal mass ejection. Now, NOAA released a space weather model that showed it impacting right around now, the end of March 4th, the beginning of March 5th, universal time. And that does seem to be lining up pretty nicely. If we look here, we see that this was at 1350 UTC on the 3rd. And this is at a distance of 0.58 astronomical units away from the sun, because it is 0.42 astronomical units ahead of the Earth in orbit right now. And it's only deviated 13 degrees. So that's basically close enough in line for us to use Solar Orbiter as an advanced probe. So it detected this big magnetic field shock from this plasma of the plasma filament that launched by. And 35 nanotesla can give you a strong geomagnetic storm. That can give you a G3, G4, depending on the configuration. Here we see our southward component. We see some volatility there right at the beginning, but then we get this sustained bucket right there downwards of at least a few hours before it went back up. And so if we have these sort of conditions here on Earth, then that again is going to be a strong geomagnetic storm. So one of a mind, thank you so much for the super thanks. And let me just turn off this, this chat message there. And so we have this solar storm impact already being measured by the solar orbiter probe. And it took 41.5 hours to travel from the sun to solar orbiter, right at the orbit of Venus, basically. And we know the distance, so we can calculate a velocity. And that velocity is 575 kilometers per second. And that gives us a travel time to the Earth of approximately 72 hours, which is 3 days. So you can add a little bit more to it because that expected impact, if we use 72 hours or 3 days, is basically 8 p.m. UTC today, and we are already past, that's about midnight. No, it's actually 1:12 a.m. UTC on the 5th of March as I'm filming this right now. But we have had that impact actually come in already. Let us check that out. Here we have our real-time solar wind data. We'll look at a bunch of stuff, but we'll just quickly look at this because we see this magnetic field impact already coming in. We see that the magnetic field strengthened, though it didn't strengthen that much. It went up to a high value of 9. We see that right there. But we had this nice initial bucket of southward component right here, that going down to -8, so 8 to -8. And we see that our KP index has already risen. This 3-hour measure of geomagnetic volatility clicking out at 4.33. But you'll notice that the solar wind velocity right here is only still around 475 or so. So it doesn't look like that coronal mass ejection has really had the main impact yet, because we didn't see a sharp jump yet. And it's only kind of been this rolling increase in the total magnetic field strength, though this southward component has gone sharply negative, but we're not seeing it with the velocity. And there's no guarantee that we're going to have this solar storm impact us. If I go to our C3 chronograph, you'll see why. Here is our chronograph going from the 1st of March to the 2nd of March, showing that plasma filament that we saw earlier on. And you'll notice that we don't get this clean full halo push right towards us. Instead, it goes here towards the south. So that coronal mass ejection launched from pretty close to Earth center direct, but it launched a little bit more south of the ecliptic plane. And so the part that is going to sweep by us, because it does seem it's already sweeping by us, it lines up in time with the solar wind. We're seeing some low energy protons already increase in their flux being measured at the L1 Lagrange point. That's indicative of them being swept up by this coronal mass ejection. But see that ring right there? That is the leading edge of that plasma filament. And we see that going down. It's when you get that ring launched directly towards you that it propagates out in all directions like this. So instead, we see it kind of going to the south, a little bit to the east. This is solar coordinate system. So this is east, that's west. So it's going like south, southeast, basically. But it does seem that it's already starting to sweep by the Earth, but this is expected to be a glancing impact. We can look at the NOAA space weather model. Of course, we've heard that before. A lot of times we've heard, hey, we just got a glancing impact and then we get a big storm. So that's why I'm making this video. There it is, looking top down. Here's the sun, there's the Earth. We're looking on the ecliptic plane. So like from north, and then we're looking down, basically like this. We see it propagating out just slightly east of the Earth in the solar coordinate system. Most of the plasma density there, but still a good chunk there. But we had to look at our south-north view here. So now we're looking at a cross section. There's the sun, there's the Earth. Look at this plasma filament propagating south of the Earth, and we get this flank impact just from the upper edge of that. This is a model. It's not reflective of reality, but they do a pretty good job at NOAA, I would say. Sometimes they've been really off, but everyone makes mistakes. In general, we use these products and they work. So they're pretty accurate overall. They show this coming in here at the end of the 4th and then really spiking there on the 5th. And so we're right now in that time window. We are starting to see a little bit of that change in the solar wind. And so it seems something's happening. But what's kind of been the case recently, or just in general sometimes, is that these sort of plasma filaments or these solar storms can actually take a while to drag out. Like sometimes you get the initial impact and they can be 6, 8, 12 hours before it really starts to ramp up. So I'm reporting on this perhaps pretty early. I've done that before where we get the initial impact, it's not that big, and then it just continues to evolve, and all of a sudden we're in a G3 storm. So that could happen. And so that's why there's this probability or this possibility of Aurora tonight. We don't know how direct or glancing this coronal mass ejection will be. And therefore, the Aurora could be fairly minor, confined more towards close to the Arctic Circle, or if it really expands into a big geomagnetic storm, let's say a G2, even G3, I mean, we don't know. But if it does that, then it could really push down into the continental United States. So we can look, in fact, at our recent magnetic field volatility to get a sense of these swings that are changing to Earth's magnetic field already. And let me just load this up. Here we go. So we are already starting to see swings to Earth's magnetic field, as you can tell with this geospace delta B map for the world. Now, delta B means for changing of the magnetic field. B stands for the magnetic field, and this is global. We see that most of these field swings are concentrated near the poles. We see our change here. So this is a nanotesla. Earth's magnetic field ranges from about 23,000 to 67,000 nanotesla. And we see that it goes up to about 400 here. It can actually go beyond that though. So even some of these really sharp red values can be beyond 400 nanotesla. They just cap it at 400. If you get to 400, you got some pretty big swings happening to the magnetic field. And this is being triggered by these particles from the solar plasma flowing down the magnetic field and interacting with the ionosphere and the atmosphere, charging it, creating powerful electric currents, which then create their own magnetic fields. When you have a movement of charge, that creates a magnetic field. And when you have a magnetic field that's fluctuating and there are charge carriers there, then that'll stimulate them to move. So they work together this way. This is electromagnetism. So these electric currents in the ionosphere and in the atmosphere, they generate these changing magnetic fields, which we then register at the surface. And that's what we're measuring with this. There's magnetic field changes occurring way out in space at the magnetopause and just in general with the magnetosphere. But these magnetic field swings are primarily from these electric currents in the ionosphere. And that's from those solar particles raining down, and that's how we get aurora. So that's what's happening right now. And we see these big pulses of activity across the northern and southern hemispheres, and that's likely to continue ramping up, I think, based off of what we're seeing already. Now, if we go to our real-time solar wind from ACE at the L1 Lagrange point, we can see just a little bit of an indication of this coronal mass ejection coming in. We're looking at 24 hours low energy protons. We see them starting to ramp up there, and then they actually cut out, perhaps because they spiked. We don't really know. But we see this big spike there in the lowest energy ones here. This is like the kilo electron volt range. So we're not looking at mega electron volt protons. But we do see that they are starting to ramp up because we are at the leading edge of that coronal mass ejection. And so this is a little bit of indication that yes, we have something coming by, sweeping us. It's not completely missing Earth. It's definitely not completely missing us. And here is our aurora view line for tonight. The estimate from NOAA, we see that this is what they expect tonight. Definitely good aurora conditions across Canada and Alaska. So you're guaranteed to have something good. You already are if you're in the eastern area, for example, with that first injection of energy. And there'll be substorms tonight, so you'll have some good aurora. But perhaps this also pushes down deeper into the continental US. And tomorrow, we see that their expectations are lower. And this coronal mass ejection likely isn't to be a super lengthy affair. Like I talked about sometimes how there's a little bit of this kind of long duration to them, but for it to go beyond 24 hours is pretty rare. And this plasma filament did not look that mean. Like it didn't look like something that could give us a 48-hour storm or anything. Let's look at that plasma filament again. Hi everyone, if you're new here, my name is Stefan Burns. Welcome to the channel. We talk about space weather, we talk about the energies here on Earth, geophysically, geologically, what's happening with earthquakes, volcanoes. We also look at the solar system, planetary resonances, planetary geometry, cosmic events, and much more. If you like the sound of that, then please subscribe. This is the plasma filament that blasted off on the 1st and is now sweeping by the Earth. Just the initial shock, it seems. Though it could just be a flank impact, and this could be perhaps all we see in terms of the magnetic field swings that we're starting to register on the planet. But I just don't think that's the case. This was fairly Earth-centered direct, though again, it did go slightly to the south. So this is the most significant thing that the sun has launched our way in a while. Hi everyone, I see you all in the chat. Hello and welcome. Thank you for being here. Let's look at what the sun is doing right now. And we can do that very easily. So we can go to our Solar Dynamics Observatory. And we'll start with our 193 angstrom view of the sun. All right, here's our sun right now in 193 angstroms. And we see some activity here. These bright regions are more active, but they're starting to rotate now towards the western limb. So we do have an increased chance of perhaps radiation storms over the next few days if they really start to pop and flare. We see this coronal hole here on the sun. So not the biggest, but it is there. And geo-effective position is from here to about there. Once it sweeps through center, then it enters into this geo-effective arrangement, and that high-speed stream can sweep by the Earth. Kind of looks like Africa. Looks a little bit like Africa, which is interesting. They always take weird shapes. What is a coronal hole though? If you're new, this is an area where the plasma temperature is lower and the magnetic field is open. So you have these particles, these plasma ions flowing directly from deeper parts of the sun out into the solar wind and typically at a high velocity. In fact, we just had a solar wind high-speed stream from a pretty significant coronal hole arrangement that brought the solar wind strength up to like 700, 800 kilometers per second. It was the fastest solar wind that we've had in a while. But we don't see any really significant activity on the sun right now. We saw that plasma filament launch on the 1st. In general, things have cooled off a little bit. So that can be good. It depends on your point of view. I don't know why this is kind of struggling. Oh, I see. Okay. Let's look at our 131 angstrom view so we can get a sense of what's happening in terms of solar flare activity. And let's just do this. Move that back over for y'all. And here we have a view that's looking at very, very high temperature plasma. This is like 10 million Kelvin. So this is the most vibrational energetic plasma on the sun. And therefore, when we see these flashes of light in the 131 angstrom view, we get, that's a solar flare effectively. So we're not really seeing anything. As you'll notice, we actually have quite a few areas that are empty and barren of sunspots. Again, these are rotating to the west. This zone does look a little bit brighter and more active, especially right there. It's kind of crackling and popping. There's a flare right there. This is for the past 48 hours or so. But in general, we haven't been seeing too much solar flare activity. We've had no M-class flares now for a while. We've only been having C-class activity. Georgina, thank you for the super thanks. And Sylvie, thank you for the super thanks as well. That's awesome. And Dory asked a question, which is, if I could be a turtle, what kind of species would I be? And turtles are my favorite animal. That's why she's asking that question. And I don't know, it's a tough one. Maybe a leatherback turtle. Leatherbacks are awesome. You know, they're big, they're warm-blooded, they can go anywhere they want in the ocean. Magnetoreception, that'd be pretty cool. So that is what's been happening with the sun over the past few days, but we have this plasma filament sweeping by, maybe just a flank, but it's sweeping by right now. Here we have our HB30 index, and this is just basically what's been happening for the past 24 hours or so. So we see that we were in quiet conditions, and then all of a sudden we had this spike up. This is 1 hour right there where the values were about 6. Which is a G2 storm. So we basically had a G2 storm for just about 1 hour. A KP index is 3 hours. It then cooled off to a value of 4. And that's why the KP index registered at a 4.667 right there. And this right there is not closed out yet because it's only about 1:30 a.m. Universal Time. So this is not finished. We could have a new injection of energy from the solar wind that could then jump that up. And actually that's occurring right now. If we go back to our real-time solar wind, let's check it out. We can just zoom out a little bit right there. Here we go. And let's actually zoom in. I think this is set to 3 days. Let's make this 24 hours. All right. Now we can see this in action a little bit more. That's that first one that gave us that HB60 index of about 6. That's 1 hour right there. This is also delayed about an hour. So what sweeps by at the L1 Lagrange point takes about an hour to arrive on Earth. So we see that, then an hour later it hits approximately. And now we see this new bucket right there. Solar wind total field strength is going down a bit. It's about 7 right now. This right there is like 7, -5. So, you know, right now the solar wind conditions aren't that spectacular yet, but there is some noticeable change here. We see this ramping up in the total field strength. We see these sustained southward components. And so I think this is probably the leading part of this plasma filament, but it could just be the very tip of kind of that plasma blob, right? And so most of the meat of it, let's say, is here, and you're just getting the edge, it's like a lens almost, like the very end of that lens, then it's not going to be that significant in strength or in terms of time duration. So that's possible. But we do see right here, here we go, we do see a little bit of a jump right there in the solar wind velocity, going from 475 to 515 approximately. So that's a 50 km/s jump. And the value that we calculated based on the solar orbiter is 575 kilometers per second. So we are seeing a bit of a jump in the velocity right now. We had this velocity approximately right here at the beginning. So it looks like these faster conditions are related to these southward components. So that is what's occurring right now with the solar wind, and that's what's happening with the sun. Just while we're at this stopping point, I would like to announce, for some of the longtime viewers will know that I've been talking about this, but it's taken me more than 5 years to do this. I have finally released the Explorer earthing shoe, which is the ultimate earthing boot. Sorry, the Explorer earthing boot. And these are the best. I've been searching for an earthing boot like this for more than 5 years now, and I started off as a customer, right, consumer, wasn't able to find one. There were other brands out there that made good boots like Vivo Barefoot. I like them because they're minimalist and they're the no toe drop and wide toe box, and you know, your feet can kind of build up their strength and it's better for your posture and everything. But they don't make anything that is grounding. So you have to either add your own copper plug or just go without it. And grounding is really important. So many health problems are caused by the fact that we're electrically disconnected from the earth now. And so I looked around a whole bunch, and basically no one was making these earthing shoes or these earthing boots specifically to the level that was needed, with an attention to biology and with an attention to the physics of electromagnetism and with the knowledge of earthing and grounding. So I just went ahead and made them. And so we got them now. We finally got them. These are 100% natural, all leather. This sole here is a thick piece of leather that does not wear out. It is super durable, just as durable, if not more, than rubber. And it's now textured on the bottom too for grip, so they're not slippery. Like if this wasn't textured, it'd be fairly slippery initially at least. Has the copper plug at the K1 meridian, and this stitching there is hemp, so it's super durable. Whereas when this was copper, cotton, it's just not that durable. But the hemp is very durable and better with water. So these are great for hiking, for adventuring. You're out in the city, you're just exploring around. But they also look really nice, as you can see. So you can wear these on a date night, and dinner, date, whatever. Like, these shoes are awesome. I effectively wore these shoes all across Europe last year. Maybe not last year. Yeah, was it last year? Yeah, last year, but it was in springtime. I wore these all across Europe last year, a prototype, and they were amazing. And now these are even better. And they're also very thin sole and no toe drop, right? There's no heel on these, right? There's no heel. And they're wide toe box, but they don't look goofy. So these are available on the website now. You can just go to the video description. The link is in there. The code for March is March Madness. So I've been waiting to announce these for a while. Someone just mentioned leather sandals. They are coming after this. I want to release one at a time. So we're releasing the boot, and then the leather sandals are also coming right afterwards. I love those too. So you can pick those up at wildfearorganic.com. Just wanted to make that announcement live on the channel for all of you that have been following that and wanting those shoes, which a lot of people have. But this has been a long journey, and during these sort of during these sort of enhanced periods of geomagnetic volatility, like we have here, we can see this very nicely with our geospace delta B. You want to be grounded. You want to make sure that you're equalized with the rhythms of the earth. And so you can do that much easier with grounding shoes, because let's be honest, we can't be barefoot all day. And if you're inside your apartment or your house, you're likely not grounded because it's elevated off the ground and there's, let's say, a lot of linoleum, let's say plastic vinyl, or it's wood. And so you're not going to be grounded in the house if you're barefoot. You can walk around barefoot, it's good for your feet, but you're not going to be grounded. You can go outside barefoot, but that's not always practical. And we can't just spend all day at the park. So if you're out and about, you're out, walking around doing chores, you're getting a coffee, whatever, the earthing shoes are amazing because you can stay grounded to a much better degree than you can with rubber, right? Rubber allows basically zero electrical current through it. Now, this leather is thick, so it's not like it's as conductive as metal, but it's still significantly more conductive than rubber, orders of magnitude more conductive. So this still allows you to ground while you're out doing stuff. That's especially important nowadays, especially with things like these geomagnetic storms or in solar maximum. They're occurring more frequent. These storms are occurring frequently because of solar maximum. That's why I wanted to get these shoes out as soon as possible, and spring and summer is coming up. So yeah, they're available. I love them. I know you'll love them too. Again, March Madness, all one word, 5% off. So that's the end of the sales pitch. But I've been working on these for so many years now. I'm so happy that the world now actually has like a good earthing boot that's biology mindful, physics mindful, electromagnetism mindful, like the attention to detail. You know, I have a lot of faith in my fellow humans, but sometimes I just wonder. I'm like, are people actually thinking out there? Sometimes I wonder if people are thinking, because I feel like people aren't thinking often. So anyways, this is what's happening right now. We see our time right there. This is right around midnight universal time, some big magnetic pulses, and we're starting to get some new ones come in at this moment in time because the solar wind is having this enhancement due to the plasma filament that launched. So right now, things have just started to cool off, but look at that most recent pulse right there. And in fact, some of this activity is even a little bit in these lower latitudes. See that right there and see that right there? This is specifically where the magnetic poles are. So you have the South Pole off the coast of Antarctica, and you have the North Pole up in this region. It's kind of stretched out, but generally in this region. So that's why you get a little bit of a greater enhancement around those areas. Unfortunately, this is not a globe. It would be nice if it was a globe, you could spin it around. That'd be really good. So that is what's happening right now with this geomagnetic storm. Again, I've been your host, Stefan Burns. One more look at the Aurora view line for tonight. And there it is. Also, someone just did super thanks. One of them mine, thank you. One of them mine for the super thanks. That's awesome. You're a top supporter. That's great. And yeah, if you have any questions, now's the time to ask them. Just type at Stefan Burns so I can see them, and I'll answer your questions. And then maybe we'll play a little bit more of the bowl before I sign off. But happy to be here to inform you today as to what's happening with the sun, with the earth, the energies. A lot of strong energies are upon us right now. A lot of chaos and volatility and more. So hoping that you're staying grounded and balanced and harmonized throughout all of that. And yeah, flip-flops are coming. Don't worry. Flip-flops are coming very soon. Now that the boots have been released, flip-flops are coming very, very soon. Julie asks, would this impact my stomach? It can. The gastrointestinal system is very much bioelectric. For example, the peristaltic rhythms are electrical in nature, which move food through your intestines. Stomach acid, right? These are all ions. And so, yeah, there can be geomagnetic activity, and perhaps if your gastrointestinal system is stressed, then that can affect it. Yeah. Again, if you want a question answered, at Stefan Burns. And Rick asked a good question. Can you get a grounding plug that fits any type of shoe? Yeah, you can buy these copper plugs and they help. They will ground you. But keep in mind that our entire bottom of our foot has a bunch of nerve endings on it. Like the entire bottom of the foot is loaded with nerve endings. And you have specifically the K1 meridian right about here on your foot, which is more electrically conductive and a natural energy point. But if you have a rubber shoe with a copper plug, let's say the bottom of this is rubber, okay? You're excluding 99% of the surface area of your foot and you're only grounding that 1%. Yeah, that 1% point is a meridian, which is useful, but you want the entire bottom of the foot to make contact. It makes such a difference. You can't get around it. No matter how you slice it, you can't get around it. I describe it more on the product page. I recommend you all, if you're interested in the boots, to read the product page in detail. I talk about all of it. Someone asked, do I do online gong guided meditations? I do. You can check that out. I have them in live streams or in regular videos. And then Miracle Hands asks, what is your take on grounding sheets? Okay, so grounding sheets. You don't want to plug them into the wall socket of your apartment or your house because that's contaminated with dirty electricity. And it doesn't matter if there's a tester or a resistor on it or any of this stuff. It's because you have a whole bunch of wiring throughout the house that's effectively acting as a giant antenna, catching any magnetic waves that are passing through the area. This could be FM radio, AM radio, television signals, all this stuff. Every single Wi-Fi router in your area, these are all alternating magnetic fields, and when they hit something conductive, they then generate oscillating currents in these conductors. And so if you then are connected to that ground system, yeah, there's a single ground rod placed right out the side of your building. That's also, the entire area is just humming with electromagnetic energy and EMFs. So yeah, even though it's plugged into the ground, it's right there in the center of all this EMF pollution. And then you lay down on that and you get all these frequencies pulsing through you. You don't want that. So you have to plug it in to a ground rod that's far away from the building with just a single copper wire. And that will avoid a lot of these problems because it's a much smaller conductor and antenna, you can say, than the entire ground system of a house. And often the neutral of a home or an apartment will feed into the ground as well and will discharge. And so then you're getting all that as well. Now the best way to go grounding is to actually get out of the house. But if you have your own ground wire and rod out away from the house and then you run that into your bedroom and you have a grounding sheet, that can be useful. But that's what most people don't understand. They don't understand electromagnetism, and so they say these grounding sheets are great, and then they actually get more EMF pollution from using them, and then they feel worse. And that's why they have these like crazy reactions when they first use grounding products, and they're wondering what it is. They think it's like a detoxification. It's like, no, it's not detoxification. You're just getting more EMFs. It's not good for you. Darcy asks, when am I getting anything attractive and comfortable for us women? Well, I mean, these are for like kind of adventuring around. They are the Explorer boot. The sandals that are coming out soon are nice, and there's also already grounding shoes for women on the website. So a lot of people love those. If you don't like them, then that's your style and your taste. Amber asks, I am an equestrian trainer. Do you think these would work well for me while in the saddle? Do they have good grip? If they work out great, I'll be sure to give my client list a shout. Yeah, they should work. I mean, they're not going to be they don't have that cowboy heel, right? And they're not going to be as grippy as rubber. No matter how you cut it, they're not as grippy as rubber. But with the traction on them, they are pretty great. So, I mean, you could give them a try. If not, if they don't work while horse riding, you'll love them for everything else already. Hot Boy Jung says, what is the frequency of the singing bowl? I don't know. It's on my phone. It's like 252 hertz, something like that. It's close to that. And Warrior of the Divine asks, can you see this solar activity affecting the cyclone bearing down on southeast coast of Australia? We can actually give that a look. Here we have that cyclone. Looks like it's about to make landfall over Brisbane. And yeah, so basically when we're looking at a weather pattern like this is a massive electromagnetic potential effectively. There's positive, there's negative potentials here, but it has a massive amount of electromagnetic charge because of all these different things in the system rubbing against each other, and they really don't know how it works. They have some ideas, but the water particles, the ice particles, all this stuff, it generates a massive amount of electrostatic charge. The air is not that conductive, so it builds and builds until you get, for example, rain coming down, which releases it slowly, or a lightning strike, which can dissipate it fairly quickly. But it's feeding itself. So you have this big electromagnetic charge close to the surface, and then you have a whole bunch of electromagnetic charge in the ionosphere 50 kilometers up. Well, if you have a bigger charge at the surface, you're going to have a stronger current going from there to the ionosphere because they will, as a capacitor, kind of work together. Whereas this area right here is just normal fair weather conditions, just pointing at a random spot with no clouds. And so the current there is going to be a fair weather current. It's going to be fairly weak. But the current in between this electromagnetic potential and that of the ionosphere is going to be quite strong because this is strong. And so that will perhaps enhance the flow of energy. And if you get more energy coming in from a solar storm impact, and it's also close to the magnetic pole, then yeah, that's exactly how you get a intensification of a weather system. That's at least possible. We have the south pole of the magnetic field in the southern hemisphere, right around here. So Australia is not that far away. And then you have this massive electromagnetic accumulation right there. I wouldn't be surprised if that intensifies. Though as it has landfall, it is going to diminish because it's not going to have the same effects. Everyone knows that. But yeah, that could intensify that cyclone or any weather pattern that is on the Earth right now. We have some others. We got this guy here in Africa. Looks like more of a tropical storm at this point, but heavy rain. And we got some stuff sweeping through the US right here. So people on the East Coast are about to have some fun right there. So they're going to be hit with an increase in their electromagnetic field locally and also an increase in magnetic field fluctuations from this geomagnetic storm. Keto Wellbeing asks, what about Mount Etna in Sicily? Slow, steady eruption since mid-February. Yeah, Mount Etna is erupting pretty frequently. I mean, it's basically been continuously erupting for decades now. So it has been a pretty significant eruption, but because it's been erupting so long, so often, it's not really notable enough, I think, for me to make a video yet on it. It has to be a pretty spectacular eruption because, again, Mount Etna is always erupting. But it is erupting, and so it's doing that. But it's a little overhyped, I would say. Tommy T asks, I heard today that there were more earthquakes off the coast of California. Is that true? Well, we've been having a lot of earthquakes off the coast of California for a while now. Let me show you specifically. Because after that magnitude 7 earthquake that we had off Ferndale or Pretoria, this zone right here, we've been having earthquakes kind of rumble in that area now continuously. And let's actually go to satellite view. But if we look at the rest of California, it looks pretty normal. Let me step over here, actually. So it looks pretty normal right now. This is the past 24 hours. If we go to the past 7 days, then we can see that earthquake swarm. But that's been occurring now for a while. If we go to the past 30 days, we see, again, because of that magnitude 7 earthquake that we had, that kind of unlocked that fault. And so there's been a little bit of a low-grade earthquake swarm in that area since. You don't see any others off the coast of California except down here. And I think that's still California right there. This is now LA, and then we're getting into San Diego once we get more down right here. So yeah, this is probably what you're talking about. That's been going on for a while. So nothing really to write home about. And we got some super thanks that came in. Thank you so much. Anne, thank you for the super thanks. And Sean, thank you for the super thanks. You're asking, what about thoughts on the pole excursion? Saw the model on NOAA's website. Models from 1500s to 2024. It meanders, and then it's headed to Siberia. Question is impact. So I have a video I can pull up for that. Let me grab that. It should, I think I know where it is. It should be pretty easy for me to pull up. But if it's difficult, I'm going to move on to another question because that's a whole thing. Here we have the movement of the North Magnetic Pole going from 1900 to 2025. And we see that's going slowly. Let me step over here because we see our time down below. And then look at the rapid movement at the very end. So it has been moving rapidly. The acceleration has slowed down a little bit. It was up to about 60 kilometers per year, and now it's down to about 40 kilometers per year. We see it slow down just at the very end then, but still moving rapidly. We have a flux lobe in North America over Canada. We have a flux lobe in the Northern Hemisphere over Siberia. This one is weakened. This one is strengthened. That explains the movement of the North Magnetic Pole. But if you look at it, the magnetic pole in the Northern Hemisphere has been moving rapidly, but in fact, it's basically located right next to the North Pole. It's just like a couple hundred kilometers away. It's not super far off the actual North Pole. And so, yeah, it's been moving quickly, but for there to be a geomagnetic excursion, it needs to be like way in Asia or something like that. It needs to be really down in these lower latitudes. And we're not seeing that with the North Magnetic Pole. Now, the South Magnetic Pole is nearly out of the Arctic Circle. It's off the coast of Antarctica, but kind of conversely, it's moving very slowly. It's not moving that quickly. It's moving about 1/4 the speed as the North Magnetic Pole. So there's this kind of duality between them where this one's moving fast, but it's actually right in the proper position, basically, proper position. And then the South Magnetic Pole is moving slowly, but it's actually kind of lopsided and off the edge of the Arctic Circle. So yeah, that's what's happening. We can't call it a pole excursion. We can call it a pole shift, but pole excursion would be very clearly that we are in a pole excursion, like the poles are now in mid-latitude regions. We're not there yet, so we can't call it a pole excursion. Haji asked a question about correlation between electric charges, electromagnetism, distortions in space-time. And yeah, it's just a whole open area, I would say. You add in quantum physics and that gets really interesting. Maybe faster than light travel, faster than speed of light travel, warp drives, things of that nature. It's a very open field. A lot of people now are talking about like 0-point energy, and they really don't know what they're talking about. Because maybe there's some like super black military stuff on that's been done. But anytime I've seen someone talking about, and I'm not a complete expert, okay? So let's keep that in mind. Like there's still a lot that I'm learning, but I've done a lot of research into this. I know the fundamentals well. Anytime I see there being like some thread or some video on like 0-point energy and levitation technology, all of it's nonsense and bogus. And some of the best evidence that people put forward is clearly like doctored animated footage that's fake. So keep that in mind. Now this is just what I see in my perspective, but based on what I know, yeah. Oh, we have another question here from Solar X Storm. Thank you for the super thanks. How do we protect ourselves from low hertz we can't hear? Well, you can't really unless you go to a location that doesn't have them. I don't really know what we mean by low hertz, whether it's sound or electromagnetism, but for the power grid, for example, in North America, 60 hertz, in Europe, 50 hertz. Those are very low frequencies, close to 0, whereas your Wi-Fi router is megahertz, millions of times per second, gigahertz even, right? That's billions of oscillations per second. The power grid is only 60. So that would qualify as low hertz. And they propagate out very nicely. So you just have to get away from them. There's really no way to protect yourself from them if you wanted to. I'm not saying you need to, but if you wanted to, let's say, because since they are such a low frequency, they can basically pass through anything. A Faraday cage basically won't work on them. But you're saying that we can't hear. So you're talking about sound. In that case, I don't really know what to tell you. Just you need sound blockers or something like that. And yeah, so it looks like things are slowing down a little bit. So let me just do one last look at what's happening with our real-time solar wind, and then we'll sign off because we have had a little bit more come in. Here we have our real-time solar wind. I keep hitting the wrong buttons. Here we go. Here we have a real-time solar wind. We've had this first bucket of southward component, which already has given us an elevation in the geomagnetic volatility. And now we have this new one right there. And it looks like solar wind strength is starting to go up again. So this is smaller than this first one, but we will see the HP index elevated as a result. Keep in mind there's about a 1 hour delay with this. So this arrives at the L1 Lagrange point about 1 hour before it arrives on Earth. And so we should just about now be having this sweep over us. So we should just about now be seeing increased geomagnetic volatility. And there's even some like live webcams of Aurora across different parts of the Arctic Circle that if you wanted to, you could check those out right now and see what's happening. Let's see where this model is. And let's actually refresh this to see if we got any fresh update on this. Because we should just now be starting to see an increase in the geomagnetic volatility again. Yeah, it looks like the magnetic field is starting to pulse back up again. And so I'll keep you up to date. I may release a video update tomorrow if this geomagnetic storm gets pretty strong, but as of right now, we have this happening. And if you live in North America, you may see Aurora if it really strengthens over the next few hours. As of right now, it is fairly mild and tame, but that could change. We see that the strength is going up and we are getting these southward components. And let us look one more time as to what was picked up by Solar Orbiter about 24 hours ago, went up all the way to 35 nanotesla. So that's a big storm. That's a big storm. If it is to hit us like that, that's a big one. Now again, Solar Orbiter, 13 degrees off of this Earth-Sun line. So it's not guaranteed, but whatever happens, like this plasma filament that launched, wasn't anything to sneeze at. When it hit Solar Orbiter, it gave it quite a shock. So we can look at that one more time. This plasma filament was no joke. So that is your space weather update. I'll keep you appraised as to what's happening. So subscribe to the channel if you'd like to stay in the know as to what's happening with the sun, the earth, the cosmos, the space, everything. I recommend you watch my video on March Madness because this month is looking pretty wild. That's on the main channel page. So I would definitely recommend you go check that out. And again, the Explorer earthing boots are available. The ultimate earthing boot. These are amazing. I love them. I love them. I love them. I love them. I'm so glad I can finally offer these out to the world. They're available international. So check out the product page, linked in the video description. Thank you all so much, everyone. Sending you lots of love and light. Hoping that you're all well. Please take care of yourself. Be mindful of your health, your physical, mental, emotional, and spiritual health. And I'll see you all very soon.